In this video, I will walk you through the exam review. So the first question is you have to convert 0 degree Fahrenheit into Celsius and Kelvin. So first thing you have to do is convert this 0 degree Fahrenheit into Celsius. For that, you have to use this equation here, where TF means the temperature in Fahrenheit, TC means temperature in Celsius. We know the value of Fahrenheit, so you should be able to find out the value in Celsius or degree Celsius. Once you know degree Celsius, then you can use the second equation and you should be able to convert into Kelvin. The second question is asking in what range, in what temperature range, the coefficient of volume expansion is negative for water. So usually any material, if you heat, its volume expands. But there are certain materials which if you heat, instead of expanding, it contracts. And water is one of the material. Water is one of the material. But the coefficient of volume expansion is not negative in all range. There are particular range of temperature in which the water, instead of expanding, it contracts. And that range is from 0 degree Celsius to 4 degrees Celsius. So in this temperature range, if you heat water from 0 degrees Celsius to 4 degrees Celsius, instead of expanding, it contracts or the volume decreases. Okay, and this we call as a anomalous expansion of water. The third question, force and velocity are in the same direction. How do we find out? In order to answer this question, you have to find out the relationship between the force and the velocity. We know the force is equal to mass times acceleration. Mass and acceleration is dv over dt. So this is the force and that's the rate of change of velocity, and this is the velocity here. So force and velocity are related by this derivative here. If the equations are related by the derivative, that means these two quantities could be in the different directions. So they are not in the same direction. Okay, they could be in the different direction. For example, if I throw a ball in the upward direction, the force is in the downward direction. That is due to the gravity, and the ball is still going up. So these two you can see is in the different direction. And similarly, if you have a projectile, if you launch a projectile, then at this point that's the direction of the velocity and the direction of the force is in the downward direction. So at the different point, the force and the velocity are in the different direction. Okay. So let's move to the different question. The static friction force can be greater than the applied force. So that's a true or false question. So I'll explain this question a little bit. So let's say you have an object on a ground. If you apply a force, let's call this force is F, and if the object is not moving, then the friction force will be in the opposite direction, and the applied force and this friction force will be exactly equal in magnitude if the object is not moving. If you increase this force will also increase, and there will be a maximum force F, above which if you apply the force, then this object starts moving in this direction. So what does this mean? The friction force or the static friction force can never be greater than the applied force. Okay, if it is greater, that means if I apply the force in this direction, the object would move in this direction, which would never happen. So if we increase this force F, if you increase this force F, then this force also increases till this force reaches a maximum value. So if I plot a graph, the graph would look like this. Okay, and that is the force, and that's the friction force here. So you see, this applied force and the friction force increases until it does have a maximum value, and this force we call as a maximum static friction. All right, so the answer would be false here. Let's move to the next one. In this question, you have to find out the distance and displacement. So how do I do that? And it is telling you to find out the distance and displacement between this time range, 5 seconds and 15 seconds. So what you have to do here, at the 5 second, find out what is the position. That is my initial position. My initial position here is, that I can write down, is 10 meter. And my final position is 15 meter at 15 seconds. And 15 seconds, my final position is 0 meter. So my final position is 0 meter at 15 seconds. So by definition, the displacement, is final position minus initial position. That's what you get. So what you get here will be negative 10 meter. Negative 10 means you moved, your final position is in the opposite direction of your starting point. Okay, and your distance would be the total path you travel. So from 5 seconds to 15 seconds, the total path you have traveled is this distance here, which is 10 meter, or simply the magnitude of this number. So 10 meter, the positive distance is always positive. Displacement can be positive or it can be negative. So this is it. If you want to know more about it, go through my other videos. Here I'm going a little bit quickly. And again, I won't solve the entire problem. I'll simply give you the idea. So in this problem, it's about the projectile. What is given is the initial velocity along x-axis. That means this is along x-axis, and this is the initial velocity along y-axis, and you have to find out the time of flight given this is my height. So time of flight means how long does it take for the object to go to the ground. That's the time of flight. So all we care about is the vertical motion. So let me write down. All we care about is the vertical motion. So what is my initial vertical speed? My initial vertical speed is 20 meters per second. That is given, you see. So what does this mean is I know from this point, if I have to write it down, so I know my initial vertical speed here. So VIY, and the height is given. The height is, what's the height? The height is 20 meters. Okay, the height of this object, from this ground here. And if you recall, I can use this equation here, y final, y initial plus VIT plus half GT square. That's the equation. So what is YF? YF is the final vertical position. YI is the initial vertical position, and I can choose my reference point anywhere I like to. So here I'm choosing my reference level at this height. That's my reference height. So if I look at this height, what is my final position? The final position of the ball would be on the ground. That means the ball goes up and comes back again to the ground. Okay, so in this diagram I'm only talking about the vertical motion. Okay, so the ball goes up and comes back here, but if you look at the two-dimensional, it goes up and comes back to the ground. But in any case, the final position of the ball will be at this point, which is negative 20 meter. Why negative 20 meter? Because everything I have assumed is from this reference level. Anything upward we call as a positive, anything downward we call as a negative. Okay, so that's the negative 20 meter, and my initial position is 0 meter. My velocity is given 20 meter. That's the time. Here it is positive because the ball, the initial vertical position is upward, and then plus half. G value would be negative 9.8. Why negative? Because if you look at this point here, the ball is still accelerating downward. The force is acting in the downward direction, so it must be negative, because everything that is downward we consider as a negative, and t square. So this is a quadratic equation. If you use this quadratic equation, you should be able to solve your time. And remember, I did not solve entirely. You have to go through all the previous recorded videos. Let's move to this other question here. So you have a 500 gram car traveling at a 30 meter per second. So you have to find out the average acceleration of the car. So what is given here is, now let's say this is your car. The mass of the car is given, and it comes to a complete stop. Comes to a complete stop. The distance is given. So the mass is, so the mass is given, which is 500 kilogram, and it is moving at a speed of 30 meter per second. So at this point, the speed is given 30 meter per second, which I call initial speed, and the distance it comes to stop is 200 meter. So this is the distance between these 2 points here. So you have to find out the average braking acceleration. Okay, so there are different ways you can solve this problem here. So how do I solve this problem? So what is the speed at this point? If the car comes to a stop here, what is the speed? The speed, you know, will be here at 0 meter per second, because it has come to a complete stop. So from this one, what you can find out is the v final is 0. So you know your initial speed, you know your final speed, you know your distance. So you should be able to find out the acceleration. So all you have to use is this equation, vf squared equals to vi squared plus 2ad. So in this equation, I know my final speed, I know my initial speed. The 2 is a constant, a we need to calculate, d is given, so I should be able to find out the acceleration. Okay, let's go to the next one. What is asking here is, what kind of collision is this one? So we have two objects here. The two objects, the mass and velocity are given, and after collision, their mass and velocity are given here. So this is before collision, and this is after collision. So in order to find out what kind of collision is this, first let's find out, is the total momentum conserved. So you have to find out the total momentum before and after collision. So the total momentum is, what's the momentum formula? The momentum formula, if you recall, the momentum is equal to mass times velocity. So the total momentum before collision will be, So the mass times velocity here, that is 20. If I look at this object here, the mass times velocity, it is 8, and I have to put -8. Why -8? Because this object is moving in the opposite direction. That's the total momentum before collision, which is 12. And now let's find out what is the momentum of this object here. Exactly the same way, mass times velocity, so it will be 15. The mass times velocity. And for this object, mass times velocity is 3. So it has to be, again, for the same reason, -12. So this is 12, this is 12. So that means this collision is possible. But we do not know yet whether this is elastic or this is inelastic. But at least we know that this kind of collision is possible. So if you remember that in elastic collision, the total kinetic energy before and after is equal. So we have to find out the total kinetic energy before collision. So what is the formula for the kinetic energy? The kinetic energy formula is half mv squared. So let's find out what is the kinetic energy of this object. Half, mass is 5 kilogram, the speed is v squared. So you see, I'm simply using half times mass v squared. Half, mass is 5 kilogram, the speed is 4 square. That's for this object. And for the other object, it will be half, mass is 4 kilogram, the speed is 2 square. And let's do this math here. And here I didn't put the negative sign because kinetic energy is always positive. Okay, even if you put the negative v and if you squared, it will still be positive. So do this math here, and exactly the same way, find out the kinetic energy of this object and this object and add them together. So once you have the total, for example, this is the total initial kinetic energy and this will be total final kinetic energy. If these two energy or the total kinetic energy before collision is equal to the total kinetic energy after collision, then that will be elastic collision. And if they are not equal, then that will be inelastic collision. All right? Okay, let's move to the next problem. So here in this problem, we have the two mass move along the same line in opposite directions. So let's draw quickly. We have one mass, we have the same mass, and they move in the opposite direction. V, let's V. The first mass is moving. The first mass is moving with a speed v. The objects collide and stick together with a speed. Okay, so what happens now after collision? These two objects stick together and move in this direction with a speed which is equal to 0.05 v. So we have one object, and this object moves at a certain speed. I can call v2i, and I can call this in v1i, which is equal to v in fact. And now you have to find out what is the speed of this object here. So the question is again, so this object is moving at a certain speed. This object is moving at a certain speed. After collision, they stick together and move with a certain speed, and you have to find out what is the speed of the second object. So this is a case of perfect inelastic collision. So all you have to do is write down the momentum equation. So total momentum before collision. So total momentum before collision is equal to total momentum after collision. After collision. That's the equation you have to write down. And what is the momentum, total momentum? By definition, the momentum would be m. The momentum of this object is mass times velocity, so which is equal to mass times velocity. Okay. And what is the momentum of this object, the second object? We know the mass. It does have the same mass, but we do not know the speed, so I'm calling v2I. And the negative sign here means the object was moving in the opposite direction. Okay. And after collision, what is the mass here? The mass will be m plus m, the total mass would be, and the speed is given 0.05v. So you solve this math and find out this v2I. That's all you have to do it. Okay, you should be able to do it. Practice. In this problem, all you have to do is write down the conservation of energy equation. So we have a spring and a mass, and if you press this mass against the spring and release, what will happen? The object will slide along this smooth surface or a frictionless surface. And what is the maximum height it can go to? In order to answer, all you have to write down is the conservation equation. So when you compress the spring, the total energy stored will be elastic potential energy. Elastic potential energy. When you release, all the potential energy will change into the gravitational potential energy at the peak. At the peak, the total energy will be only the gravitational potential energy. So what's the formula for elastic potential energy? Half k x squared. What is the formula for the gravitational potential energy? mgh. From this one, you should be able to find out the height. Okay, let's move to the next one. Okay. So here we have a 5 kilogram object moving along the x-axis, and the potential, this is given as a potential energy graph here. Okay, and the kinetic energy is given at the origin, which is 120 joule. And you have to find out the speed of the object at 6 meters along the x-axis. That means at this point. So what is basically asking here is, let me clear this one. So what you have to write down, the total energy at this point must be equal to total energy at this point. So what are the total energy at this point here? Total energy at this point. The total energy is kinetic energy plus potential energy. Kinetic energy plus potential energy. And I have to write down the total energy at this point too. So kinetic energy plus potential energy. The question does say that the kinetic energy at this origin is 120 joule. So I know my 120 joule. And what is the potential energy? The potential energy I can find out from the graph is about 22 joule. About 22. And we do not know the kinetic energy at this point. So I'm simply solving for the kinetic energy. But we know the potential energy at this point, which is 29 joule. 29 joule. And these two must be equal because of the conservation of energy. From this one, you should be able to find out the kinetic energy at this point here. Once you know the kinetic energy, once you know this value, then you know that kinetic energy is equal to half mv squared. And you should be able to solve the speed of the particle at this point. Okay. So now let's move to the second other problem. So we have a student slides 80 kilogram ducks across the level floor, and the distance is given. Coefficient of kinetic friction between the disc and the floor is 0.6. How much work is done? Okay, so let's draw the free body diagram first. So we have an 80 kilogram, and then you move this one 40 meter. The distance is given. The distance is 40 meter. Coefficient of kinetic friction is given, which is 0.6. And now you have to find out the amount of work done. So how do you calculate the amount of work done? The amount of work done is given by force times the distance. And in this case, the force will be in the opposite direction, and the distance will be in the forward direction, the displacement in fact. But how do we find out the magnitude of the force and the distance here? So you know the force, this force is the friction force, that's the only force acting. So which is given by mu times the normal force and times the distance. Mu, the normal force, is equal to m times g times the distance. And from this one you should be able to find out the work. Okay, so that's the formula. I'm not going to do completely, but I think you got the idea. Let's move to the next one. I think that's the last one. So we have a crane that lifts a 420 kilogram steel beam at a distance of 117 meter. How much work does the crane do if the beam accelerates upward at 1.8 meter per second squared? Neglect frictional forces. So we have a crane that lifts a 420 kilogram steel. The height is given, and you have to find out the work done. So how do you find out this one? And this one is speeding up or accelerating at 1.8 meter per second squared. This problem and this problem is very identical, very identical. So all you have to find out, so you know the formula for the work done. The work done formula is again force times the distance. So you have an object, so how do I find out how much is the force? We know the distance, the force would be m times g, but as the system is accelerating, the normal force would be different. So first you have to find out the normal force. So by Newton's second law of motion, the net force is equal to mass time acceleration. Okay, this is mg. So n minus mg equals to m times a. So if I solve it, I will get n equals to m g plus a. M mass is given, whatever mass is given, g value is 9.8 and a is 1.8 because the system is accelerating upward. So from this one I get my normal force. So in fact the correct formula would be to write down n times d. N is the normal force here. Okay, this is not moving at a constant velocity. So we know now m g plus a times d. If you plug in, you'll get the answer. I think this is it for this review session. If you have any questions, write to me. So go through this problem, try to do it by yourself, and again, if you have any questions, write down in the comment section below. Thank you very much. Have a good one.